So in our last video, we ended with this claim that A union B cross C is equal to A cross C union B cross C. And now what we're going to do is we're going to prove it. Well, really, I guess instead of saying claim, I should say conjecture, but those really mean the same thing. So conjecture, prove this conjecture. So I'm proving that these two sets are equal. So remember, your proof has to contain two parts. So part one of your proof, you need to show that A union B cross C is a subset of A cross C union B cross C. So we're going to start with, like all of our proofs, we're going to start with an outline of our proof. So what would the starting point of our proof be? I need to take an element in the left-hand side, but that's a Cartesian product, so I've got to take an ordered pair, an x comma y, in A union B cross C. And what do I need to conclude? I need to conclude that this element, this ordered pair, is also an element of this other side. So the end of our proof is going to be, make sure I give myself enough room here, the end will be that x comma y is in A cross C union B cross C. So to be in this union, it means either xy is in A cross C or xy is in B cross C. So that's where I need to get to. So we're going to go back to our start, keep that end in mind. Well, this ordered pair is in this Cartesian product, so that means that x has to belong to A union B and y has to belong to C. Well, if x is in A union B, then x is in A, or x is in B. Because we have an or here, we're going to have to proceed with cases. So case 1 is that x is in A, and case 2 will be that x is not in A. So if x is in A, well, we have that x is in A and y is in C. That means my ordered pair xy is in A cross C. And that's one of the two things I needed to get to. If x is not in A, well, we said that x is in A or x is in B. Since x is not in A, x would have to be in B. But this means x is in B, and we still have that y is in C. So xy is in B cross C, and that was one of the two things I needed to get to. Okay. So we've completed the outline of the proof, and now we just need to write the formal proof. Let's suppose that xy is in A union B cross C. And as you're writing this, make sure you go back and you reference your outline. Okay. Then what we said was x is in A union B and y is in C. since X is in A union B, we said that X was in A or X was in B. And then from here, we used cases, so we proceed with the two cases, and those two cases are X is in A or X is not in A. So case 1, assume X is in A. Since X is in A and Y is in C, then this ordered pair is in A cross C. Case number 2, assume that X is not in A. Since X is in A or X is in B, and I know that X is not in A, X has to be in B. Now that I know that X is in B and Y is in C, then the ordered pair XY is in B cross C. So in either case, XY is in A cross C or XY was in B cross C. So that means that this pair is in the union, and we've now established that A union B cross C is a subset of A cross C union B cross C. So in our next video, we'll prove the reverse containment. We'll prove the second part of this proof in order to establish that these two sets are equal.